I derived this figure from Microsoft's Entity Framework documentation. It provides a partial high-level view of how Entity Framework accesses and manages data for an application. It shows how commands flow to the various layers of Entity Framework and how the results are returned, how Entity Framework uses the entity data model to process data, and how the application is isolated from the gory details of the data store. Now, it may look a little bit scary, but let me kind of describe all the different moving pieces, and then I'll drill down into some of the details, the more interesting parts as I go. So what I'm going to talk about is a general description of how an application uses Entity Framework to interact with data from a data store. The application uses either Entity SQL or link queries to access or modify data. And I'm not going to talk a lot about Entity SQL here, but it's a form of SQL that was implemented in Entity Framework, and it provides an alternate way to perform Entity Framework queries. And as you can see in the vertical arrow kind of in the middle left of the diagram, you can use Entity SQL either to access the objects directly, or you can bypass the objects and go, it's essentially a lower level access to that entity client data provider in order to access the data. All right, but these requests, again, either by Entity SQL or by link, they're handled by object services. And that's the gateway to the data, and it handles object materialization to populate the entity data objects. It creates them in memory and populates them with data. And then the object services also keeps track of changes that the application makes to the data. So again, Entity SQL query or a link to entities query that uses object services has advantage of all of those services. And then for queries that request data, object services returns the materialized objects to the application. And that's that up results arrow in the upper right-hand part of the figure. One of the things that object services does is it converts the queries that you create into a command tree. And that's just a generic structure that it can use internally to generate actual requests to the database. And then it passes those command trees to the entity client data provider, or just the entity client, and manages the communication between object services and the data providers that actually communicate with the database itself. And then the entity client returns any results from the database as an entity data reader, which is a tabular data format that object services can use. And then the application can also make Entity SQL queries directly to the entity client, as I mentioned, and that bypasses object services entirely. All right, so then the entity client translates those commands it receives into the SQL command tree that the underlying data store understands. Now, I'm talking about this as though we're accessing a SQL Server data store, but it'll do the work for other data stores as well, whether it's SQL or some other language or whatever is necessary in order to translate those queries. All right, then it passes those commands to the appropriate ADO.NET data provider, same ones that you've probably been using in .NET applications for years. And then it returns any results in the form of a DB data reader, which is a fast and efficient way to read data. And then to access the data provider communicates with the data store. So the entity data model provides the metadata that the entity client needs to manage the flow of data between the application and the data store. And that's that rectangle on the left-hand side of the figure. The model uses a conceptual model for the structure of the entity data objects that are used by the application, and then a storage model of the underlying data store so that it can properly access a piece of data from the correct table and field, whatever you request from within the application. And then mapping, the arrow between the two, provides a link between the data exposed by properties of each entity data object and the fields in the data store. Okay, so again, this all probably seems pretty complex, and really in practice it is. But it isn't necessary to have a deep understanding of all the internals of Entity Framework to use it effectively. But using it effectively does require some level of knowledge about the various components. And so what I'm going to do now is talk more about a bit of detail about the various entity framework components so that, again, as you develop applications, you'll understand something about what is happening, which is going to let you make more effective use of entity framework. All right. So the first thing I'm going to do is talk about a little bit more about some of the entity framework design tools and methodologies. So first up is something I've mentioned several times in the course so far, the Entity Data Model Designer. This is part of Visual Studio and lets you work with the model graphically instead of messing around with a very convoluted XML model that provides the metadata underneath everything. You're welcome to work directly with the XML and create it from scratch if you want to, and that's pretty much what you had to do with the very first version of Entity Framework. But really, it would suck away just about any productivity gains that you might have had from using Entity Framework, and then some. Developers lacking unlimited amounts of time to finish a project are really more likely to use the designer. All right, so I've shown you in earlier sections of the course how the designer works and how you create a model. So use the wizard to complete the work and derive a model that was based on the AdventureWorks LT database. And I explored the various objects that the wizard added to the project. And once again, although the model designer supports by far and away most of the entity data model features, there are a few very less commonly used features that you can't implement in the designer. It just doesn't support them. You're not likely to encounter those obscure features very often, and this course is not going to come across any, so they're really pretty rare. So the model designer lets you map tables, views, stored procedures, and functions to your entity objects. And then, acknowledging the iterative nature of software development, the designer lets you update the model from the underlying database, so you can add database objects you didn't initially include when you created the model and incorporate subsequent changes to the database in your model. Now, when it comes to brand new data applications, there are two broad ways to approach building the application. You can design the object model first and the database later, or you can build the database first and the object model later. So the first option is often called top-down design because you're building application components first that sit on top of other layers, including the database. The second option is bottom-up design because the underlying foundation of the application, the database, comes first. Top-down design places the business rules and architecture of the application of the highest value, and bottom-up design puts the emphasis on strong data organization. Now, neither methodology is necessarily better than the other. Each one fits some development teams better than the other, and even some applications better than others. A project dominated by DBAs is likely to favor a bottom-up design methodology, while one dominated by developers is somewhat more likely to favor a top-down design, depending on how comfortable that the developers are with data design. If you're building a new application that'll use an existing production database, then you're inherently taking a bottoms-up approach because the database already exists. Entity Framework supports both methodologies, although not at the same time in an application. And it does that by providing three primary ways to build an application. One that supports bottom-first design, and two that support top-first design. The first one is database-first design, and this was available with the initial release of Entity Framework. This is the technique that I used when I created the AdventureWorks library, based on objects in the existing AdventureWorks LT database. The Entity Data Model Wizard obtained the database schema and created the entity data objects for the tables that I selected within the wizard. The existing database schema shapes the entity objects using this database-first technique, although you can modify the resulting objects very extensively. So it can almost be non-recognizable compared to the underlying tables. Then there's a model-first design option, and this was introduced in version 4 of Entity Framework. If the database doesn't yet exist, you can create an entity data model using the designer in Visual Studio from scratch, or you can write the XML for the EDMX file directly, if you're so inclined. When you're ready, you can have Entity Framework create a new database that corresponds to the model that you've designed, shaping the data and storage to that model. If you later make changes to the model, the designer in Visual Studio supports recreating the database with those changes. So it's really a very flexible system. And then the third primary way is code-first design. This was released in version 4.1 of the Entity Framework. And here you write plain old CLR objects, or POCOs, P-O-C-Os, which are regular .NET class objects. And Entity Framework will create the data store from those objects. So you don't have an intervening model that you create within the designer at all. Because Code First works with an implied model at runtime, so it doesn't need that EDMX file. This technique is the purest form of top-down design. Because you design your POCOs, your plain old CLR objects, your .NET objects, with no foresight about how the data will be persisted within a data store. It's really pretty amazing. Now I want to talk just a little bit more about T4. One of the primary services that the Entity Data Model Designer provides is code generation. That's ultimately what you want to do. You want to create the code so you can use those objects, instantiate those objects in memory, and start accessing the data through them. Once you've defined the Entity Data Model, the designer generates the code for those objects. And it uses Visual Studio's Text Template Transformation Toolkit, or T4, in order to generate the classes in the awltmodel.designer.cs file. This provides both a standard mechanism for generating code and a way to customize the templates and therefore the resulting code. So you have control over the actual code for the objects that Entity Framework generates. Now, customizing T4 templates is not for the faint of heart because it requires both the template language as well as its code generation mechanism, in addition to what you need to know about generating those Entity Framework objects. But T4 is not specific to Entity Framework. Visual Studio uses it extensively just about any time it automatically generates any kind of code file. So the good news is that any T4 skills that you pick up customizing Entity Framework code will transfer to other code templates as well for other project types that you may use within Visual Studio. Object Services, as its name implies, is responsible for managing all of the objects in Entity Framework, particularly the entity data objects. Its key task is to manage and handle the differences between a relational database, or any data store for that matter, and .NET objects. This makes Object Services a key part of what makes Entity Framework work for data access, and it takes on a huge responsibility in your application. It provides an entity object class and manages all entity objects that inherit from that class. And there's actually an additional object that you can use as well. Object Services are responsible for 4 primary tasks within Entity Framework. It exposes an API that generates entity data objects that you write queries against. It also performs query transformations that take queries it receives from an application and turns them into command trees that it passes to the entity client for execution against the data store. It also performs object materialization. When the results of a query return from entity client in tabular form, Object Services instantiates the appropriate entity data objects, like the customer object, for example, and populates those objects with data from the data store using that tabular form of the data. It also adds the object to a context, which is the duration of communication between the application and Entity Framework. And then finally, Object Services tracks the state of data objects and updates the data store. A state manager retains the original data and values read from the data store as well as any updated values so it can perform an optimized update of the database. To provide these services, Object Services makes use of the conceptual model portion of the entity data model. The data it exchanges with the entity client is tabular, in a form that's related to the structure of the entity data objects rather than as it resides in the data store. This simplifies the process of materializing the entity data objects. Now, Object Services provides a lot of ways to customize how it manages data flowing between the data store and the application, depending on how you use and configure Entity Framework. All right, now a bit more about Entity Client. Entity Client takes care of communicating with the data store and managing data conversions between its structure in the database and a form usable by Object Services to materialize the entity data objects. This means that the Entity Client has to know both the structure of the data in the data store as well as the details of the entity data objects. So it needs to use the full entity data model, including the conceptual model, the storage model, and the mappings between those two. So you can start to see how all these pieces fit together. The Entity Client doesn't connect directly to the data store. Instead, it relies on one of Microsoft's favorite patterns, the provider pattern. Data providers for the various supported data stores provide a standard API that the Entity Client can use to perform data operations on the store. And the data provider knows how to translate those commands to a form that the target data store knows how to respond to, whether to retrieve or to make changes to the data. These are the same data providers that you may have used with classic ADO.NET applications, although it has to be a version of the provider that's updated to work with the Entity Framework. And many currently available providers have been, if not all. Now, the key benefit to using data providers is that Entity Framework can work with any database or even any non-relational data store that has an available data provider. You can use SQL Server and make Microsoft very happy, or you can use Oracle, any OLADB supported database, and others. The entity data model doesn't need to have knowledge of what data store you're using or even its schema, as long as it has a usable storage model available to it. Another benefit of using providers is that you don't have to learn how a particular database system works to access its data. Entity Framework takes care of transforming queries into a form that a particular database can understand, and then transforms the data results to a form that any framework can use to materialize the entity data objects for you, all behind the scenes. And as I mentioned, you don't even have to use Object Services to query and access a data store. You can also write Entity SQL queries to directly access the Entity Client and its API. This does have the advantage of eliminating both a layer in the Entity Framework stack as well as object materialization in the Object Services, which results in better data access performance at the cost of far more complex data access code in the application. And that's because the application can no longer use straightforward link queries and nice clean entity data objects to access the data. All right, so using Entity SQL directly to bypass Object Services is definitely an advanced technique that you're probably never going to use. And so it's not covered in this course. So for the most part, consider the Entity Client to be an API used only by Object Services. And then there are a number of services that Entity Framework provides to an application. With each new release, Microsoft expands these services to support a wider variety of application types and development styles, as well as various data access scenarios. This means that with each new release, Entity Framework is available to more developers, in line with Microsoft's goal of making Entity Framework the data access standard, at least within the Microsoft development stack. So one of these services is support for plain old CLR objects, or POCOs. And this is one of the most important new features that was released back in Entity Framework 4.0. And that was in the time frame of Visual Studio 2010. And that's the ability of the Entity Framework to manage entity data objects that don't inherit from entity object. And this is called POCO support, and again referring to plain old CLR objects. Instead of being limited to creating and using entity data objects generated from the Entity Data Model Designer and the Wizard, you can get Entity Framework support for any kind of custom business objects that you develop within .NET. POCO support enables a whole bunch of programming styles and methodologies, such as domain-driven and agile development, which were previously pretty incompatible with Entity Framework. And it also enables unit testing. Now, POCO support requires that the Entity Framework be able to remove the dependency on entity object, since POCOs don't inherit from that class, unlike the entity data objects that are generated by the Entity Data Model Designer. And an entity framework does this by allowing its object context class to obtain relationship and change tracking information from POCOs so that the POCOs need have no knowledge at all of the entity framework. And this is one of the necessary features that enabled code-first development back in Entity Framework version 4.1. And then another service that it provides, Entity Framework provides, is data binding in .NET applications. Data binding has long been a standard technique for connecting data to controls in the user interface, and dates back to some of the earliest days of Visual Basics rapid application development innovations, going back to Visual Basic 6 and before, even before .NET. So a key benefit of data binding is that you can configure the binding at design time, and it often requires little or no code to implement, unless you need to go beyond the basics, which sometimes you often needed to. Entity Framework has full support for data binding in .NET applications, so that you can use entity data objects as a data source for data-bound controls. Again, this is in the user interface. And that includes Windows Forms, Web Forms, and Windows Presentation Foundation or WPF applications. ASP.NET Web Forms applications provide an entity data source control that let you declaratively bind entity objects to the user interface, while support for binding Entity Framework objects is baked deeply into ASP.NET MVC. The bottom line here is that you can use entity data objects much the same as you've probably used other objects, including the generic ADO.NET data objects, to bind data to the user interface.